Hey, Vlad here, devinsider.com. Welcome to another video. In the previous video, we took the trees and ripped them out of the sets. And in general, after investing over 20 videos into sets, trees, and a little bit of stack and a little bit of recursion, the time has finally come to talk about maps, which are highly misunderstood creatures. Today, we're going to do a very short video where we're just going to have the rudimentary methods on sets. We're going to be able to add elements and to remove elements, and that's pretty much it. As always, we're in the Ubuntu virtual machine and we're running Sublime Text, which is the text editor of my choosing, and we have a plugin for Sublime Text called Terminus, which emulates the entire terminal for us, and it runs SBT, which reruns the test every time we save the file. Remember in the initial video about sets, I gave you a few examples of where sets are being used, and one of those examples was functions. And I'm not referring to the fact that sets are basically functions from element to boolean, or in other words contains. I'm rather referring to the definition of a function. A mathematical function is defined by its domain, which is a set of values that can be used as input for this function. So we're going to be calling them keys today, and by its codomain, which is a set of outputs which can be produced by that function. We're going to call them values today. So we have input, output, or keys and values. Well, maps are data structures which, in addition to being a simple function, they also store the entire domain, so the entire set of values, as their data. So for sure you can ask a map to give you the value when you give it a key. So you give it a key, it gives you the value, but you can also, what you can also do with a map is you can ask it for the entire set of keys, right? And why stop there? You can also ask it to give you the entire set of values. A very subtle property of maps that should not go unnoticed is that maps are data structures, so you can add and remove elements. So we're going to be adding pairs of keys and values, or key value pairs, but what we shouldn't forget is that we're also allowed to remove keys, and when we remove the key, the associated value also gets removed, and thus a map is not a function from key to value, it's a function to key and an optional value. So the value might be there or it might not be, same as a key. So essentially maps are partial functions, or in some languages they're called dictionaries, and some people also call them by their full name. So instead of just saying map, they would say associative maps, because what maps do is they basically associate a key with a value. All right, enough talking, let's write some code. So the first thing we're going to do is we're going to create a file, and we're going to call it map.scala. Map.scala. Right, and I'm going to reveal it in the sidebar, and it should be where the set is as well. So the basic idea is, and let's put it in into the package homegrown collections, as everything else is. So the basic idea of the map is going to be this. It's a final class map, and it's going to be parameterized not only with an element as the set was. In fact, maybe we should do that. So we have the set over here with an element, but the map is going to have two parameters. It's going to have the key, which is going to be invariant, and it's going to have a covariant value. Right, so a map from string to dogs is a subset of a map from string to animals, right? So it's covariant in the second position, and it's going to have similar structure as in the set. So in fact, maybe I should do that over here. To save a few lines like that. Well, actually not to save a few lines, but like to have some more readability. So we're going to have a private constructor, and in addition to having this basically partial function, we're going to call it value of, which is going to take the key and return the option of a value. What it will also have is it will have the entire list of keys. So it's, I'm saying a list of keys, but I'm really serious about meaning a set of keys, right? So it's a set of keys. Right, so effectively this is a domain, and this is sort of like the function that will retrieve the codomain. And because of that, we can also say that a map is a function, right? So it extends a function one, and I'm going to do that. And over here I'm going to say final override def apply, key comes in, option off, value comes out, and it's just value of key. And it would be kind of cool if Scala would allow me to say over here, to say something like override val, and it would understand that that this lambda, that this function function object would actually override or actually implement a method. That would be kind of cool, but Scala doesn't have that, and I don't know if any languages actually have that, but that would be kind of cool. Yeah, so that's pretty much it. This is this is sort of the essence of the map. And while we're at it, let's also go and have a companion object. Similar to the companion object that we have on the sets. So if I collapse the sets, we have a companion object over here with a private def apply, which is just going to create maps for us like this. So we're going to give it keys instead of key, and maybe we should do that, comma, value of, which is a function that takes a key, produces an option of value, right? It will produce a map of key value, and what it will do is simply new map keys and value of. Right, so even though we can't add anything to the map or remove anything to the map, like this is the essence of the map. And by the way, this is not a typical encoding, but well, let me save this and let me actually do that again so that we see only the map. It's through the set down there, and I don't want it over there. So let's just have map at the top and the terminal at the bottom. So this is not a typical encoding for the maps, because the problem over here is that the algorithmic complexity. So if we ask, for example, the map if it contains the key, then the algorithmic complexity is logarithmic, which is still good, right? Because we just go to the key set and we'll ask, hey, doesn't contain it. But if we're retrieving the value, we will have to go through these functions, and we will see later when we implement the add function that it's going to be very similar to the very initial implementation of the sets that we have, where we're basically concatenating functions. So we'll have to go through all of these functions to find this value actually. So the complexity is going to become linear. So this is not a typical implementation for maps, but however, for educational purposes, I believe that this is the best one to understand what maps are. Maps are a bunch of keys and the function that can take the key and maybe produce a value. And as part of the essence of the map is the fact that the key should be public. The key should be exposed. So from the outside, you should be able to say map dot, give me your keys. And also we're going to have a final lazy val for values. So the values is going to be a set of value, right? And we're just going to say keys map, and we're going to say, okay, if I have the key, then let's look up that key. And let's get it out. Now, get usually throws an exception, but in this case, if add and remove are implemented properly, then the exception will never be thrown in this case. Okay. In fact, we're going to use this. I'm going to call it pattern, but it's not really a pattern. We're going to use this this code quite a few times a bit later. So I'm just going to create a private def that does that. I'm going to call it unsafe value off. So it gets the key, and instead of returning an option of a value, it's going to return a value directly, right? So it's just going to do value of key, and then it will call get. So now we can just take this and replace this entire thing with just that, right? Because this is exactly the function that map wants. Okay, we don't have tests yet, but in fact, this is what we're going to do. We're going to start adding tests now. I'm going to have how do we usually have it? We have usually tests on the left, right? So I'm just going to do that, and I'm going to create a file called map suite, and it's going to be in test Scala user. There we go. Okay, so in fact, we're going to open set suite, and I'm going to copy maybe this whole part like this. Going to copy that, paste it over here. Going to call it map suite, and the first test I'm going to call it hello world, and I'm just going to say one should be one, and we're missing a brace over here, right? So let me save this, and in fact, let me press enter over here, and let's run only these tests. So let's do tilde for continuous running, test only user dot map suite. There we go. So it should be only this one test, and let's make it fail. Let's say 2 should be 1. All right, everything works as intended. Let's reverse that real quick. So I'm not going to write a bunch of tests because we spent like 20 videos of writing very similar tests. So tests are important, therefore I have tests. But you shouldn't like watch me writing them. So what I'm going to do is most of the time is I'm just going to copy paste them. So the first one that we're going to have is the test that will force us to write the empty method. Okay, so now it's going to say empty doesn't exist. So basically it says apply on an empty map should yield none, right? So map.empty, you give it a random string, should be none. And by the way, this is also the reason why we moved the random string in the previous video to the companion object. So that's interesting actually, that the tags did not update, so it jumps over here, and it thinks that it's over there, but it's not over there. To user, no, hold up, package, And there we go. So this is actually where we have the random string function. It's in the package object user, and therefore we can access this from anywhere in the task, because all of our tasks are going to be in the package user, right? So let's add the empty to the map. So we're just going to go here, and similarly to the way the stats are doing that. In fact, maybe let's open the stats. Let's always have them sort of open as a reference. So we have an empty. In fact, empty in stats is implemented in the factory over here. So it's going to be very similar. Empty, so now it has key and value instead of just element, and it's producing a map of key value, and just going to call apply with set.empty and with this, right? So first of all, let's move the empty to the top like that, because I want to be able to read my code top to bottom. So empty calls apply is right here. So in fact, let's just say keys is set.empty, and value of is, yeah, it's basically this. So basically it says whatever you're going to give me, the result is going to be none, always, whatever you do. This is an empty map, right? The keys are empty, and whatever you give to the value of, it's always going to return none. Okay, so the next thing that we're going to do is we're going to add the add function and the apply function, the one with the var args, the one that the factory has, but we can't use factory because we have only one parameter in the stats, but in the maps we actually have two type parameters. Okay, so so basically we need something like this final def apply. In fact, maybe I should copy that. So the thing is that all the tests that I'm gonna be copy pasting now, they're already using this var args method. So let's put it over here. So they're all ready and waiting to call this method, which takes a key and a value, and it doesn't want it wants an element, but the element is going to be a pair, right? So an element is going to be a tuple of the key and the value. It wants the other elements, same thing, right? So it's a key, not keys, it's key and the value, and what it produces is a map. Not of element, it produces a map of key value. Okay, like this. And what it does is it's called empty, call empty, it says add element, right? So all we need to do now is we need to have add. So let's have it over here. So it's going to be final def add. In fact, maybe we can copy add from foldable factory. Foldable factory over here. This is where we have add. Let's copy that. Put it over here. Let's have some more space. Okay, so it's just a map. So it used to be just a super and an element, but in this case we're talking about values which are in the covariant position, right? So we're gonna have over here value, and because of that we're gonna call this super value, right? So as soon as we have that, and this is not going to be a map of super values, it's going to be a map where the key is the same, but the value might be different because it's, you know, it's in the covariant position. So we're going to have that. We're going to throw an exception over here, and let's just see if it compiles. It doesn't compile. What does it say? Type mismatch. Found element type, required value. Let's go down and see what's up. Oh, the problem is probably over here in the add function. So if we go to add in the map, yeah, so the input is actually the entire pair. So it's going to be not the super value, it's going to be key and the super value, right? So now it should be fine, but obviously there's no implementation. So before we add the implementation, we're going to add a bunch of tests. So let's go here. Let me close all of this. So we're going to have map suite, and we're going to add a bunch of tests for the add. All right, so I got them in my buffer. Let's go here. Let's paste them all. Let's save it, and everything should compile, but all the tests should be failing, obviously, because we're throwing an exception over here. So let's go and implement add. And basically the idea of add is, the first thing is let's just unpack the key and the value, right? So this is the input, and what we want to do is we want to create an entire new map, right, which is going to have a different set of keys, and the value of is also going to be different. So the keys is simply going to be the keys add key, right? So we just add the key to the set of keys, right? So we're expanding the domain, and the value of is going to be another function, right? It's very similar to this continuation kind of way we implemented the sets in the very beginning. So some key comes in, and if that k equals to that key, then we're just going to return it, right? And otherwise we're just going to ask all the other functions, and this is where this linearity comes from, right? So because over here we're creating a function that basically calls another function, right? So it's a line, right? There are no trees or anything, and so this is why this is not a typical encoding. So that's actually it. A very beginner mistake, but it happens. All right, so now this is fine. And what I'm going to do now is I'm actually going to replace this with a partial function, because remember, wherever a function is required in Scala, you can also use a partial function. And if you use a partial function for value of, it's going to look a bit prettier. So we could say if it's exactly the same key, right? So it's basically this line, if k equals key. So if it's that, then we're going to have some value. And otherwise, if it's just some k, then just call the value off, right? So that thing is a bit shorter, and that's why we're going to keep using that. So the next thing that we're going to do is we're going to add a test for remove. What do I have them? I have them over here. Let me mark them all. Oh, that's a lot of tests. All right, so we got remove, and I'm going to add them over here. Okay, we're actually going to go through all of them in just a second. Okay, something is not. Oh yeah, I didn't even add the signature for remove. Now the difference for the signature of remove is if you go to the SAT and go to the SAT and we go to remove. So add and remove for the SATs, they look pretty much the same. Some element, or the essence of the element, some super element comes in, and the set comes out. So the signature looks the same, right? But for remove, for the maps, it's actually, if I copy that, bring it down, I'm going to call it remove, right? So what we're removing is not a pair of key values. It's enough just to give me the key, right? So if you can give me the key, then we're all good, right? And therefore, also for remove, you should not have the super value, right? Because the value is not even in scope here. So what comes back is this. So so that's what we need. And in fact, because of that, we don't even need the curly braces, right? So the entire implementation for remove is exactly the same code. But instead of adding the keys, we're just going to remove key. And if it's exactly this one key, we're going to use none. And this is also the reason why I use a total function instead of using the partial function, because it's just easier to remove things. I can just say, okay, whenever exactly this key comes in, just return a none, and that's all. What's up? Not found value key. Oh, I call it input key. There we go. Ta-da, it's green. Cool. So let's actually take a quick look on the tasks that we have, because copy pasting is it's good to save time, but it's still important to see which kind of task we have. So we have this one, add on an empty map should yield a new map with one element. So this is how we create maps. We have this var args factory, right? So we can pass it a bunch of things. So we're going to pass it, we're going to say, okay, this map has only one element, the key is first, the value is second. And then if we're asking, hey, what is the value for the key first? And the value is some second. And what is the value for the key second? It's none. And add on a non-empty map should yield a new map with two elements. Yeah, I'm basically using the var args method here, but the implementation of var args, it just calls fold left on the initial sequence of the elements, and it just calls add a bunch of times. So basically what the test says, that if you have already one element and you're adding another one, then it still should be good. It should have a map with two elements. So you create it sort of also looks like a function, right? So first comes in, second comes out, second comes in, first comes out, and so on. Adding the same element twice should replace the value. This is an important thing. Remember, the keys is a set, right? It's a set of values. So if we add an element with the same key, see, second twice, then the value is just going to be overridden, right? So if we're asking it for the second value for the value with the key second, the result should be second and not first. Okay. What else? Remove on an empty map should yield an empty map. That's kind of boring. Remove on a non-empty map should yield a new map without the element, obviously. So we have a map. We're asking, hey, does it contain the element? Yes. And when we remove the key, then if we do the same thing, it should return none all of a sudden. Removes only the element in question. We have a map with two elements. In fact, let's have it like that. Like that. I prefer to have it like that. Where's the remove? There it is. So we have this map, and we're asking, does it contain the elements? Yes, these are the values. So now we remove the first element. So now if we're asking for the value of the key first, the value should be none. Remove removes only the element in question. The ordering test. So in this one is basically the mirror test, where we remove the second key instead of the first one. So we remove the second one, and the other one we remove the first one. So it's basically an ordering test, the same as the name says. And remove comments should ensure that all the elements are distinct. Yeah, so you have the same key twice, and then you remove the key, and all of the keys should be removed now, and keys.size should be 0. remove should remove elements from both sides of the tree. Basically, I copied that from the sets, the stats. So we have 1 to 3 equals value, and then we have 1, -2, -3. Because remember that backed by sets and sets are backed by trees, right? So and this is a right-leaning tree. This one is a right-leaning tree, and this one is a left-leaning tree, which is unbalanced, right? So just gonna make sure that the last element, like this one, is on the right, it's getting removed, and this one is on the left, and it's getting removed. All right, that's all that we need to know about add and remove from maps. The next test that I'm going to write, I'm actually going to write this one out because I like this. We're actually going to test that the map should be a function 1. Function 1, right? So essentially, we're going to tell the compiler, hey, I'm going to have a function from string to option of int, and what I can use on the right-hand side is I can use a map. Right, so I can say, okay, so if the string is Alice, it's sort of like a pattern match, right? It's like a partial function. So if Alice is 5 and Bob is 3, so for example, this could be age or something, right? And Frank could be 5, then f of Alice should be some 5. Let's copy that. So Bob is going to be 3, and Frank is going to be 5 as well. And f of Eric should be none. Right. So basically, we can use maps wherever a function is required that matches that. By the way, the maps in the standard library, they're actually a function from string to int and not an option int. So so if you call a map like this and it doesn't contain the element, it will actually throw an exception. In fact, let me show you this. So if I start a regular terminal, I run Scala, right, and I'm just going to create a map from, I'm just going to say 1 is the Roman 1, like that, right? And I'm going to say res0 of 1 is 1, but res0 of something that is not there of 2 is going to throw an exception. Right, it says no such element exception. So how you deal with this is it also has a method called get. So if you say get to, then it will behave the same as our maps behave, right? So it's just going to return and it's going to return a none. It's going to return an option. So so if you wanted to do similar code that we did right over here, like this. So what do we have here? We have int to string. So if you have val f equals int to an option of string, right? If you just use res0, right, which is the map, it's not going to compile. But if you do res0.get, then eta expansion is going to kick in and it's going to do exactly what exactly what we're doing. It just that our way is basically a little bit safer. So in our way, there is no way to ask for the value that is not there, or to ask for the key that has no associated value. All right, let me close this and let's see what we have next. The next thing is the test for the keys. So we're just going to record the fact that keys should be public, right? So keys should be exposed. Oh, let's just say public. So we're just going to have an empty map with int string, and we're going to ask it for the keys, and it should be sat empty int, right? Because if it's not a val, this is how Scala works, right? If you don't have this val over here, then it's a private val. Right, so the test are going to compile. It says, hey, value key is not a member of map, right? So we have to explicitly have a val over there. And the same thing for the values. Let's go here, test. We're going to have values should yield a set of values, right? In fact, let's be fancy and say it should yield a set of values. The probably was a hyphen codomain. I'm not really sure. All right. So let's say that we had a map with 1 and the value is 10 and 2 and the value is 20. Then if we ask it for values, then it should be a set of 10, 20, right? There we go. Should be fine. All right, so we're pretty much done actually. Let's just add a few methods for fun. So remember for set, we have these methods like is singleton, we have is empty, not empty, and we have the sample. So let's just add them as well. Let's go down over here. So we have add and remove. So let's go here and say final def is empty, which is a boolean. It's basically keys is empty, right? And not empty boolean equals not is empty, and is singleton, which is a boolean, It's going to ask the keys if they're Boolean, if they're singleton, and for the sample, which is going to give an option of the entire pair, right? The key value pair. It's going to give a sample, right? And what it will do is it will say keys.sample map, and then we have the key, right? Because keys are just keys, right? And then we're going to go key, and we're going to ask to retrieve the unsafe value of the key, right? So now we have 4 of these, and I'm just going to copy paste the test for them because the tests are kind of boring but necessary. So there we go. Gonna go to the very bottom, insert these tests. Let's see. So we have the is empty on an empty map should yield true. Well, obviously is empty is true, non-empty is false. Boring test. Is empty on a non-empty map should yield false. Obviously. Singleton. Let's actually have like as soon as I have like 2 elements in something, then I just prefer to drop the lines like this to have this. There's one, except for this one. Maybe it's super tiny. Why not? Let's keep it like that. Or maybe no, maybe not, maybe not. It's just like visually more clear. Okay, there are 2 elements, A B to A, right, like this. And remember this fancy thing from Scala test. It so if you have some sort of collection, you can say that it should contain one of this one, because the order of the maps is not guaranteed the same as with the sets. I don't really care about order, so I'm not really sure as a sample, is it going to return me this one or is it going to return me this one. And also I sort of forgot to mention this, but there's no need to return an option of value over here, right? Because we're basically looking for the key, and if there is a key, then we're going to get its value, and the value will always be returned. So it's called, unsafe value of, because when you're declaring a function, you have no idea where it's going to be called from. We're constraining it a little bit to be in the private scope, but still, I can be silly and call it like in a random place and give it a random key, and it will explode. It's just that I'm making sure, with the tests and basically with the test only, that I'm only calling this unsafe value of in the places that are being covered by the test, and this is how I'm sure that it's okay to call them. And this is pretty much all I got for you today, actually. Let's open another terminal, add everything, git commit -am, and this should be the video 20. And I'm just going to call it rudimentary maps. Rudimentary maps. Yeah. So I'm sure that you have realized by now that when I'm recording videos, I don't have the exact name for the video, which is why commits and my video names are don't always correspond. Also, the name of the video can be edited later. This commit is kind of hard to edit, so let me push that. Let's go check it out. So if I refresh that, then it should be rudimentary maps over here. So we just added map. It's super tiny for now, just 65 lines. We can add things, we can remove things, we can do like rudimentary things like is empty, non-empty, singleton, sample, and so on and so on. We also refactored set a little bit, and we added a bunch of tests for the map suite. Look, we have like 230 lines already, which is kind of cool. All right, so that's pretty much all I got for you today. It took us around 20 videos to cover sets, but I did that because I wanted to cover some very important computer science fundamentals, like for example the algorithmic complexity or those trees and the rotation on trees. We even did the red-black trees and so on. We even did like trampolines and stuff. But now I hope that my videos are going to be more shorter, more like crispy and fun, because right now I can use more and more of the language because I was constraining myself quite a bit, and also I can lean on the very important computer science fundamentals for from the videos that are already made. So yeah, everything is going to be more fun from now on, I hope. And yeah, but we're not done with maps. This is only the first video. We're going to have probably 2 or 3 more videos just for maps alone, because as of right now, as you can see, we just have the add and the remove function. And yeah, so at this stage, I'm just blabbering. So it's been Vlad, devinside.com. Like this video if you did. Subscribe if you want to improve the developer inside you. And most importantly, take care.